Welcome back to a exam explanation video. Today we're going to be covering Module 6, Inquiry Question 4. And so this is on the applications of the motor effect. We're going to be going through the 2020 Independent Physics question of question 28. Worth 9 marks. So we have a table that shows the results of an experiment between the relationship of a rotating motor, its particular speed, and the net voltage across the coil. The motor was connected to a 12V power supply. Assume there was no load, no load attached, and friction effect was effectively 0. So no load means like no resistors. No resistors on the actual circuit. You have your values here, you have your voltage here. In the very first question you dealt with, you need to graph this data in this table here and put it into this chart here. So that's the first step we need to do. It's worth 2 marks. So 1 mark will obviously be for plotting the data, and the other mark would most likely be drawing a line of best fit at some point. So let's start. So at 0, we are at 12. Might even try and use a slightly thicker pen. So here we go. At 1000, we're about 11.3, so around about this point here. At 2000 we are at 10.1, so about here. 3000 about 9.8, so we'll put that there. 4000 3.93, 9.3, sorry. 5000 we have 8.7, and then 7.6 at 6000 there. Okay. The next part is obviously to draw a line of best fit. Now I'm doing this freehand, but you should really try and use a ruler to do this. An absolute must. Whoa. Not too bad, I reckon, for freehand. The last bit a little bit dodgy, but there you go. So we see a reduction in the net voltage as the RPM goes up. So I just might write that down. So the net voltage goes down as the RPM increases. Okay, so let's move on. Question B, it says explain. In terms of physics principles, why is the net voltage across the coil decreasing, and predict the minimum value when the motor reaches its maximum speed. Now firstly, let's use our Q method to just sort of break down this question for ourselves. You can obviously use different colors if you want to highlight the question. So firstly, always circle in your command term. Our command term here is explain, to show cause and effect. The next thing we want to show is physics principles. So these are definitive. We want multiple if possible. And then the concepts we have is net voltage is decreasing, and then we have prediction of a minimum value at maximum speed. So we want to address all of these parts together. Okay, so let's get started. Why does the net voltage decrease? So decrease in net voltage is due to the production of back EMF. Okay, so That kind of identifies what's happening here. Let's kind of relate it to the scientific law. So we have the production of back EMF that opposes the direction of supply voltage to the supply voltage there. Let's just start with that because that makes it slightly easier for ourselves. Now, what we have here, the direction of the EMF, so the direction of EMF, or induced EMF in this case, induced EMF is predicted by Lenz's law, as to oppose the original change. So oppose the original change. In this case, that's our rotating motor. Okay? So there's that. The next part we need to talk about is our second principle. So we talked about one scientific principle, Lenz's law. Our second one will be the law of conservation of energy. So this obeys the law of conservation of energy. Okay, the reason why it obeys the law of conservation of energy is because the kinetic energy of the motor rotating will be equal to the electrical energy that then produces the electric current, then that produces the magnetic field. So this obeys the law of conservation of energy as to oppose the motion of the motor, converting kinetic energy into the electrical energy, which then converts into our magnetic field. Okay, now the question we can also answer is why specifically the law of conservation of energy is obeyed here. So if induced voltage was in the same direction as the supplied, the motor will continually accelerate producing infinite amount of energy, producing an infinite amount of energy, hence violates the laws of conservation of energy. Obviously, if you're going to write it as the shorter case here, make sure you do mention that's how you're going to mention it later on. So that manages to answer this component here, this component here, and maximum operating speed here. Okay. We can also say at maximum operating speed, the motor's rotation speed is constant. Okay. Now the question is, what's the minimum value? So the minimum value, so at max speed, we are predicting net voltage is going to equal to 0. Okay, and that answers the question for us. We want to firstly go through the explanation, we want to make our prediction, and then we want to do an explanation of why the net voltage is decreasing, like so. Moving on to question B. So on the basis of his graph, the student concluded that the net voltage across the motor is directly proportional to the speed of the coil. Okay, so this is a conclusion by the student based on the graph. Evaluate, and the question asks to evaluate the student's conclusion. Okay, let's have a look. If you actually have a look at this graph here, it is not directly proportional. A directly proportional graph is actually a positive linear chart here. What you can see here, this is actually inversely proportional. How do I tell? I can tell by, as the rotation speed increases, the net voltage across the core actually is decreasing. So by that aspect, the core speed and net voltage is actually inversely proportional rather than being proportional to each other. So, firstly, we want to write down our judgment. You can just write it out nice and clear so the whole world knows what you think. Conclusion is inaccurate, so incorrect conclusion. Okay, we know that, or we know firstly, the speed of the coil and net voltage are inversely proportional. So they're inversely proportional to each other according to the graph. Okay, the question has 3 marks, so let's look at where else we could be missing another mark. So the conclusion he made was the net voltage across motor coils are directly proportional to speed. What we can actually interpret from the language used here, there is a generalization here. There is a generalization based on his graph. Now, obviously, it is not a valid conclusion to make, or not a reliable conclusion to make, because he's only done one experiment. So he hasn't looked at multiple different experiments and compared them together to see whether or not that is true. So we also have a reliability issue. So this conclusion is also not reliable as the student has only performed one experiment. They need to do multiple repetitions to ensure that that's the result that they get. But either way, even if they did repeat it, you can see the conclusion is incorrect because they looked at the wrong part of the graph. So perform one experiment, repetitions are required. So those are the 3 components you need to put in to get the 3 marks here. So I'm hoping from what you can gather from this video, a nice little explanation with how we can apply the law of conservation of energy and Lenz's law to the production of back EMF in motors, and also the net voltage in a motor. If you found this video helpful, please by all means give a like. But if you just want to keep watching some more of these videos, please do so as well. We are looking at Module 6 Inquiry Question 3. There are some other nice videos that you can look at in the playlist that can guide you on your journey to understanding more about electromagnetism. So until next time, take care, and that concludes our exam explanation video.